Hello everyone, I am Dr. Velamani P.S., Department of Computer Science, University of Science and Technology, Meghalaya. In this video, we are going to see about network interface card, checksum error detection method, and switching techniques. Network interface card. Network interface card, in this diagram, we can have a look on this device. This particular device is computer network hardware device which is embedded with the motherboard of a laptop or desktop computer, and it will be used to connect with the LAN. So in this diagram we can see that the network interface card, this is the point, and it is connected with the processor or memory, and this is a LAN connector. The LAN connector is going to connect with this network interface card, and this particular network interface card, which is used to transmit and receive data format on LAN. So from LAN, this network interface card is used to receive and transmit the data to where? Exactly to the processor or memory. So the process of this processor or memory is generate outgoing data and handles incoming data. So that is the process, it can be handled by this processor or memory. Then this entire block computer attached to a network. So this will be there in our system. So to our system, this LAN cable will be connected in this particular point. So this is a simple information about the network interface card. So without this interface card hardware, the LAN cannot be connected with our system. So the functionalities, working functionality of network interface card. NIC gathers the data that is to be sent from the application. So it will gather the data. Then after data gathering from the motherboard, and it transferred to a small buffer. So that a small buffer which is available in the NIC, temporary storage on the card. So the NIC adds its own address plus destination address where the data is supposed to be sent. So NIC's temporary storage will store the data, and it will add the address of the destination of the data, and it will send the data. So NIC calculated the checksum for the data in the buffer. The checksum is the error detection method which will be used in the NIC buffer level. We will see that checksum error detection method process. That is a mathematical calculation which we can use by once complementing the numbers. Then information arranged into a frame format, then the transmission can be done through the network. So the frame, the digital transmission in between the devices, the frame, that is the data unit. The data unit is said to be a frame. The particular data unit can be transmitted throughout the network at this moment. So we'll see one by one. checksum error detection method. So the checksum error detection method, before seeing to this error detection method, we need to know some of the technical words and its meaning. Then only that will be useful for us to study further. So terms to be noted: bandwidth. Bandwidth is nothing but the maximum amount of data transmitted through a communication channel at one time. So the maximum amount of data transmission. Throughput, actual amount of data transmitted, that is throughput. Broadband, any transmission medium that carries several channels to transport data at high speed, that is called broadband. Then these two terms, packet frames. So generally we'll use this term at many situations. Packet is a small segment of a larger message. It is a small segment, small unit, that is called, even we can say sometimes, packet data unit. So packet is a small segment of a larger message. Then frame, as I told that already, is a unit of data used in digital data transmission system. Unit of data. So generally frames that will be there in 32 bits, and we'll see that in our further slides. Yeah, packet is a single data unit, PDU. So now the checksum error detection method. So here we can see that error detection scheme in between sender and receiver. So in sender, the bits, the data, how this can be arranged, and the receiver, how it can be received. We'll see to it. So in sender, if there is an information, if there is a frame, it will be converted into m bits, that is 8 bits information, each and every segment. So a frame consists of different segments, m bits like that. So the particular message is having m bits of segments. We are going to keep this last one, this particular m bits, that is for the checksum. This checksum, and this checksum will be generated by using the ones complementation of the m bits. We'll see step by step. So after adding this checksum, and we will send this particular binary values will be transferred to the receiver. Now we can see this particular message. We are checking all values are 0. If there is no error, if checksum value is no error, then the receiver might receive all the information, the exact information which the sender wants to send to the receiver. In case if any one of the bit is not properly received, we will get the last value as 1. Then we'll get last value as 1, or any value maybe 1 in this particular method. So this is a simple logic. So the last checksum, in case if we'll get all or 0, then there is no error. We received the proper message from the sender. In case if it is not 0, then somewhere we have not received the proper message from the sender. That is the logic here. So now let us see how this can be explained. So the data is divided into k segments, each of m bits. Yes. In the sender end, these segments are added using ones complement arithmetic to get the sum. So ones complement arithmetic, we are using this. This sum is complemented to get the checksum. The checksum segment is sent along with the data segments. At the receiver end, all received segments are added using one's complement arithmetic to get the sum. Again, the sum will be complemented. So, if the result is 0, the received data is accepted. Otherwise, the data is discarded. The checksum detected all errors involving an odd number of bits. It also detects most errors involving even number of bits. This checksum is mostly used in network layer and transport layer, then at data link layer level. So these layer levels, this particular checksum error detection method will be used in this OSI model 3 layers. So the sender, in between the sender and receiver, how the process can be takes place as steps. Messages are divided into m-bit units. First step, the generator creates m-bit unit called checksum. The generator checksum is sent with the message. So that was the thing. The checksum is sent with the message. The checker creates new checksum using the message and sends checksum, that is in the receiver side. The new checksum value is 0, which indicates the message is accepted without any error. Otherwise, the message is discarded in case if it is error. That is a method. So then now let us move to the switching techniques, how the data will be transmitted from the sender and receiver among various network hardware devices. Switching techniques. So two or more devices are connected to form a network. To have a dedicated path in large number of networks, these switching techniques will be used. So dedicated path we are going to determine by using this switching technique. A switched network consists of a series of interlinked nodes, which is called switches are our network devices. Switches are capable of creating temporary connection between devices connected. The techniques of transmitting data from sender to receiver by finding out the best path in large networks. So we need to find out the best path in between two devices along the largest network. In largest network, there might be multiple paths linking sender and receiver. We'll see this in our next slide, how this can be. Before that, some of the types are there in the switching techniques. Number one, circuit switching. Two is packet switching. Packet switching is having two different types, that is datagram, virtual circuit. Number three is message switching. So now let us take the circuit switching, how this can be takes place. So the sender is their device. In between sender and receiver, this is the network. The network is consist of 1, 2, 3, 4, 5 routers or maybe switches or whatever it is. So that data needs to be travel from device A to device B, which will create a standard path. Like from this router, data will travel to here, then finally it will reach the receiver. That is the circuit switch. So there is a direct connection in between the sender and receiver in an unbroken path. That is switching technique, circuit switching technique. So, for example, if we consider the telephone switching equipment, it establishes a path that connects the caller's telephone to the receiver's telephone by making a physical connection. So, with this type of switching technique, once a connection is established, A dedicated path exists between both end until the connection is terminated. So caller is calling the callee, and once the call is connected, there will be no disturbance, and that call will be existing until and unless the call will be getting over. So that is the scenario in between sender and receiver in the telephone wired networking. So routing decisions, the router. So the the routing decisions, routing between one device network hardware device to another device, how this can be takes place. See, this routing decision must be made when the circuit is first established, but there are no decision made after the time. The first decision is done, then after that nothing will happen. So it will follow the same direction. The computer or sender initiating the data transfer must ask for a connection to the receiver or destination. Then connection will be established. So the once the connection has been initiated and completed to the destination device, the destination device must acknowledge that it is ready and willing to carry on a transfer of data or information in between sender and receiver. Advantages of this circuit switching. The communication channel is dedicated. Oh, standard connection, the standard path is established here. So that is the major advantage here. Disadvantages, possible long wait to establish connection. If somebody is already in line, then we need to wait to establish the connection. So 10 seconds more on long distance or international calls during which no data can be transmitted. More expensive than any other switching technique. We'll see that in further slides because a dedicated path takes separate connection and it is more expensive also. So inefficient use of the communication channel because the channel is not used when the connected systems are not using it. So that is inefficient use which we can say at this moment. Packet switching, that is the second one. The packet switching can be seen as a solution that tries to combine the advantages of message and circuit switching and to minimize the disadvantages of both. So two methods are there in packet switching. Number one is datagram. Number two is virtual circuit. Let us see one by one. Datagrams. So datagram is nothing but the packets, data packet data unit. So from the receiver side, the data will be received from the sender. So the network can be takes place like this. The sender is going to send the data packet, for example, 321 in this sequence, and it will find out the router, it will find out the nearest one. But the data cannot move, the routes cannot be established specifically. Any data packet can move at any router based upon this network traffic. For example, one is moving towards here and 2 is moving towards this router and 3 is moving towards this router. So accordingly it will travel to reach this receiver. So who will reach this router first? Accordingly it will reach the receiver also. For example, 2 is going to reach the router first and it can be released from here, and the receiver may receive the 2 data packet 2. Then for example 3, then 1 will be there. So at this moment we can see the sequence is missing. The sequence of the data packet will not be there. Here 3 2 1 is the sequence of the data packet, but here 132 is the data packets. So we need to reassemble this for the exact thing. So that is the datagram switching. So it is happening in the network layer level. So each packet is treated independently. So as it indicates, each packet, for example, that 1321 separately, we are taking that these packets referred as datagrams. So here packets are referred as datagrams. Here these switching devices are routers. Routers are used as a switching device. So each data contains header with source address, destination address. That is the point along with the sequence number. So as I told that 2 is going to travel from this router to this router, it might have the header information as well as source and destination information. So that is the point which we need to keep it in our mind. So source address, destination address. Source address here is this particular source address, sender address will be there in this bucket. Destination address, receiver address will be there in this bucket. And with that, the sequence number, which sequence it needs to move, maybe either it may be the first one, second one, third one. With that sequence number, that packet will be moved. Intermediate nodes used the destination address to forward the datagrams to the right destination. So the intermediate nodes which is nearest to the another router, these routers are said to be nodes here. This will be used to reach the receiver properly. In datagram switching, there is no fixed path due to reason being each packet travel independently in the network to the destination. So that is the case which we have seen here. It is also called as connectionless network. So there is no proper connection in between sender and receiver due to the reason being the data can be the data packets can be travel in multi directions in multiple paths to reach the receiver. So the advantages of the datagram switching, it is efficiency which is better than circuit switching. So each and every packet is traveling in different path, and so there is no dedicated route and all. So it can be easily reach the receiver bit fastly. Disadvantages, transmission delay will be high. Sometimes the transmission delay, if it is a dedicated path like circuit switching, so properly it can move. Sometimes if some routers or some nodes are highly loaded, at that moment the transmission get delayed. Now virtual circuit switching. See, in this picture, we'll find out exactly the frame, the entire frame, the combination of all packets or a combination of all datagrams. It makes this frame for the digital transmission, data transmission in between the sender and receiver. So the data, how this can be moved, the entire frame can be transmitted from one node to another node like this. Finally, it will reach the receiver. So the how the source address and destination address can be maintained, we'll see to it. A virtual connection made in between sender and receiver to define a path. So that is the first stage. All frames travel in the same path. That is a fact in case. So every frame consists of forwarding table along with source and destination address. So forwarding table is maintained here. So how the forwarding table maintained here? So it consists of incoming and outgoing. So incoming, which port it will be used, what is the label, and outgoing, what is the port and what is the label. So these things will be maintained in this particular phase. Now the three phases: setup phase, data transmission phase, teardown phase. Setup phase, virtual path will be created, setup request to the destination, and the acknowledgement signal will be received by the destination. Then the forwarding table will be created at this moment in each switch or router. Data transmission phase, data transmission will be takes place. Tear down phase, after the data transmission, it sends tear down frame to device B. So the device B, for example, the device B will receive, after receiving the signal, after receiving the data, it sends the tear down signal to the device A. That signal is in the form of frames. Then after that, all router delete the entire frame table. So once the connection is established, data is traveled and data is received by the receiver. So after that, the table which is generated, that will be deleted. So in such a manner, this virtual circuit switching will be functioning. So if all routers table will be deleted, then after that it will be ready for the next connection establishment or next data transmission. Now the message switching. So device A and the device B, how the message will be transferred. The thing is that entire message will be transferred here, then entire message will be transferred here, entire message will be transferred here. If this message is in this particular router, there is no message will be existing in this particular nodes. So entire message will be transferred step by step manner via this router all or switch to reach the receiver. So it happens in application layer level. So that is the point which we need to note here. Application layer level, this message switching will be happen. This is the top layer level. In message switching, there is no need of establishing a dedicated path between sender and receiver. It uses store and forward mechanism. Yes, store and forward mechanism. Just this message will be transferred to this particular router, and it store this message, and it forward to this router, and it store it the message, and it will forward. That is called our store and forward mechanism till to reach this receiver. So the message is transferred as a complete unit and routed by the intermediate nodes at which it is stored and forwarded. So each message is treated as independent unit. Each node stores the entire message and forward to next node. This network is called stored and forward network. So stored and forward network we are naming in such manner. The network device should have sufficient storage capacity to store the incoming messages, which is not suited in real-time applications. So the network devices store and forward method we are using. So we need to have some memory also to store this messages in the network device. So thank you. So with this, we can finish this presentation. So in this presentation, we have covered the various type of switching techniques, then the checksum error correction, error detection method, and various type of switching techniques. Thank you very much.